Whether it's on a factory floor or just in a local workshop, we're surrounded by some incredibly powerful machines. They cut, they shape, they build our world with a force that, honestly, we often take for granted. But with all that power comes a hidden danger. So, okay, let's dive into this really critical topic, how to stay safe around hazardous machinery.
And let's be super clear about what's at stake right from the get-go. We're talking about injuries that can change your life in an instant. When a machine is unguarded or just isn't used the right way, the risk of something like an amputation is very, very real. It's no joke. And get this, the numbers are pretty sobering. According to the Bureau of Labor Statistics, hundreds of workers are killed by hazardous machinery every single year. And the thing is, every single one of those is a preventable tragedy. That's why understanding machine guarding is so absolutely essential.
So, before we can even start talking about the solutions, we have to really, truly understand the problem. We need to pinpoint exactly where these dangers are lurking and what kind of harm they can actually cause.
This quote from our source material really just says it all, doesn't it? It's a direct, powerful warning. And notice, it isn't just for the person operating the machine. It's for anyone who maintains it or even just works near it. The risk is universal.
And the range of injuries you can get is, well, it's wide. It can start with things like cuts, lacerations, or punctures. Those are the most common. But it escalates, and it escalates quickly, to crushing injuries, broken bones, and, yeah, as we've seen, the catastrophic result of amputation.
Okay, so where do these hazards actually exist on a machine? It might seem complicated, but it's not as complex as you might think. We can basically break down almost any machine into 3 core areas that need to be safeguarded. First up, and this is usually the most hazardous spot, is the point of operation. This is the business end of the machine, right? It's where the saw blade meets the wood, the drill bit hits the metal, or the press stamps out the plastic. It's where the work actually gets done.
Next, you've got the power transmission system. The easiest way to think about this is like the engine and the drivetrain of the machine. It's all the parts that take the energy from the motor and deliver it right to that point of operation. It's the muscle.
And finally, there are the operating controls and any other moving parts. And this is a pretty broad category. It includes literally anything that rotates, moves back and forth, or travels in a straight line while that machine is up and running.
So when we say power transmission, what are we actually talking about? Well, it's not some abstract concept. It's the stuff you see every day. Flywheels, pulleys, belts, chains, cranks, gears. And every single one of those parts can grab a piece of loose clothing, or worse, a body part in a fraction of a second.
All right, so we've mapped out the danger zones. Now for the good part. Let's talk about the solution. Engineered controls, which we usually just call guards, are your first and most important line of defense against all these hazards.
So the big question is, what does that protection actually look like on the job? Well, there are several different types of guards and safety devices, and each one is designed for a very specific purpose. A lot of the time, the most effective method is actually the simplest one, a fixed guard. This is just a permanent physical barrier that makes it impossible for you to reach into the danger zone. And because it's a permanent part of the machine, it provides the highest and most reliable level of protection you can get. Then you have something you might call smart guards. An interlocked guard is actually connected to the machine's power source. So if that guard is opened or removed, it automatically shuts the whole machine off. It literally makes it impossible to run the machine in an unsafe state. It's a fantastic fail-safe. And beyond those main types of guards, there's a whole suite of other safety devices. Things like presence-sensing devices, which use light curtains to stop a machine if you get too close. There are restraints that physically keep your hands away from danger. Safety trip controls like tripwires are for a quick emergency shutdown. And two-handed controls make sure your hands are busy and safe during the machine's cycle. Now, all these engineered controls are fantastic, but here's the thing. They only work if we use them correctly. The technology is only half the battle. The other half is about our behavior around the machines. And that brings us to a simple, memorable set of rules for staying safe.
Let's run through these safety 7. They really just boil down to a few key principles. First, if a guard isn't there or if it's busted, don't use the machine. Simple as that. Second, never ever try to get past a guard. Just remember that AUTO rule. Don't reach around, under, through, or over. And finally, always use proper procedures like lockout, slash out for maintenance, and please use tools like push sticks, not your hands, to clear jams. The full list is right here, and believe me, every single one is critical.
So we have the knowledge, right? We know the hazards, we know the rules. So now the most important part is turning all that knowledge into consistent, daily safety habits that you don't even have to think about.
And really, it all comes down to this. It's a simple contrast between the do's and the don'ts. Do make sure your guards are in place and working. Don't even think about using a machine if they're missing. Do use tools and aids like push sticks. Don't ever reach into a machine that's turned on. Following the do's and avoiding the don'ts is what's going to keep you safe day in and day out. So, I'll leave you with this final thought. Picture this. The machine's been checked out, the guards are all in place, they're working perfectly, everything seems ready to go. What's the very last safety check you need to make before you start that job? The answer isn't on the machine, it's you.